Assalamu alaikum. Hope you all are doing good. My name is Muhammad Harun Khan and I'm one of your TAs for this course. And this video is in particular to help you with question number 3 in assignment 1. I was wondering that it would be good to know the basics of filtering, that how to apply how to apply a filter on an image. So what are some of the basic parameters of filtering, and what are some of the challenges that you might face while you are applying the code. So I'll also be discussing the pseudocode. Right now, in digital signal processing, we understand that what we mean by filtering is the suppression of unwanted frequency components in a signal. Now, in case of images, we do not have any frequency components. What we rather have are pixel values. What we want to do is we want to suppress all the unwanted pixel values from an image, or we want to modify or tweak the pixel values of the image so that the image represents the desired properties. These are some of the basic applications of filters, and there are several kinds of filters. In general, how do we define a filter mathematically is that it's an n by n matrix where n starts from 3 and is an odd number. Now I have a 3 by 3 filter with all the entries of the kernel as 1, which means this is an average calculating filter. What it does is, on each pixel value where the filter is being applied, it will calculate the average and assign it to the output image for the respective pixel. In this case, I have a 3 by 3 filter and I have a 5 by 5 arbitrary image. There are two different cases for filtering. Number one is when you pad the image, and number two is when you do not pad the image. When you do not pad the image, that means that you apply the given filter on the image directly without modifying the image. Hence, you are not able to preserve the shape of the input image in the output image. We will go through the basic process and then you will get to understand this idea even better. I have a 5 by 5 image and I have a 3 by 3 filter. Now I will place the center of this filter on each of the pixel values in the image. So you can see that for only the pixel values that are within the bound of this box, the filter operation will be valid, because whenever I place the center of this filter on any of the pixels inside this box, then the filter completely overlaps with the image. If I place the center of the filter on any of the pixel that is outside this region, for suppose if I put the filter on the bottommost and rightmost element, which is 1, then the filter will go outside the bounds of the image, and in this case it would not be a valid filter operation on that pixel, so we will ignore that pixel in the output image. This entire Only this entire region that is bounded inside the box will be valid for filter operation. And as I've already mentioned, that since we are not padding the image, we're considering the case of no padding. In this case, the output image will not preserve the shape of the input image, and hence it will be a 3 by 3 image, um, where as a result of filtering. And as you can see, we have placed the filter on the pixel value 1 1, which is 3. We take all the pixel values that overlap with the filter, and we calculate the average. So the average of this entire region would be the average value that we would replace for this pixel in the output image. How this mapping is done, we will discuss that exactly in the pseudocode. You can see that the pixel value in this case is 1 by 1, right? The position of the pixel, and it is mapped to the position 0 0 in the output image. How this mapping is done, it's a very simple, um, you have to use the padding factor that we will discuss later. I hope you so we have seen that by using filters and averaging filter, you apply this to for blurring the image, which means to denoise the image. You can get rid of unwanted pixel values. You can get rid of sharp pixel values that do not resonate with your image pixel values. So it's a very powerful and useful tool which has a lot of applications. This process continues for all the valid pixel values and the new image is formed, which right. Now let's talk about padding. As we discussed earlier, that when you apply filter without padding, then the output image does not preserve the shape of the input image. So in case if you want to preserve the shape of the input image in the output image, in that case you pad the image with rows and columns of zeros. And why zeros? Because you are able to preserve the inherent properties of the pixel values of the image without affecting it in the output image, and you are able to apply filter operation on the entire image. That's the best thing about using zeros for padding. If you do any other pixel values, that might affect your computation or might affect the average values of the pixels. Now the padding factor, so for padding, that you're supposed to know by how much amount you need to pad the image. In case of if your filter is a 3 by 3 filter, then the padding factor would be different. If it's a 5 by 5 filter, then the padding factor would be different. So the padding factor is a function of the dimension of the filter. The ceil function is just here for precaution. You're not supposed to do this. It would work absolutely fine without the ceil function too. The padding factor is given by the formula dimension of the filter minus 1 divided by 2. Now, if the dimension of your filter is 3, then the padding factor is 1. If the dimension of your filter is 5, and by dimension we mean the order of the kernel of the filter, right? If the filter is of the order 5 by 5, then the padding factor would be 5 minus 1 divided by 2, which is 2. Let's try to visualize what the padding factor represents, because this will help you understand well. So in this case I have a 3 by 3 image, and I have a padding, and I'm using a filter of 3 by 3, so the padding factor is 1. In this case, as you can see, that in order to make all these pixel values of the image valid for filtering operation, I added one row of 0 to the upper side, one row of 0 to the bottom, one column of zeros to the left, one column of zeros to the right. Why 1 on each side? Because the padding factor was 1. Now in case if I'm applying a 5 by 5 filter on this 3 by 3 image, then in that case the padding factor would be 2. In this case I will add 2 rows of zeros on upper and lower side and 2 columns of zeros on left and right side, because the padding factor was 2. And in this case this entire region now becomes valid for filter operation, because when I will place center of a 5 by 5 filter on this 3, it will completely overlap with the image. Though these values are 0, which will not significantly contribute in the average value, but at least my algorithm or the code that I will implement will consider this as a valid operation, and it should, because the image is now 5, because the image is, because the kernel now completely overlaps with the image. Though these are 0, but they are elements of the image itself. And in this case you can see, when I'll place a 3 by 3 kernel on this pixel, it will completely overlap with the image again, and all of these pixels would be valid for filter operation. Now let's look into an example and walk through the pseudocode for filtering. Now it's absolutely fine if you're intending to follow a different code, but this pseudocode that I have written is based on primary calculations of padding factor and fundamentals of filtering, so it would really help you. I would recommend to follow this pseudocode. It will make your work easier. Now I have a 3 by 3 filter, right? And I have again a 5 by 5 image, which is a grayscale image, right? We are talking about grayscale. You can also have RGB images when each element of the nested list that contains your image, because you use list data structures to store images in Python. In that case, each position of the nested list will contain 3 values. In grayscale, you only have a single value. When you're able to do this successfully on grayscale images, then you can easily replicate the process for RGB image too. You just have to do it thrice rather than once for grayscale, and it will absolutely work fine if your code was working correctly for grayscale images. So I have a grayscale image, I have a 3 by 3 filter. So let's calculate the order of this filter. The order of the filter is 3. Hmm? And as the padding factor is a function of the order or dimension, the padding factor is 1. Now your function in the assignment requires you to have an input variable that is called pad. If pad is true, then the output image will be equal to the shape of the input image, and if pad is not true, then it will be not. If pad is true, then the output image will be of the height and width of the input image. And so you have to create an output image that will consist of entirely zeros, and its height and width would be the height and width of the image. If pad is not equal to true, you can use, I have all mentioned a note here, you can use numpy library for these operations. These are very simple functions that you can use. You can talk to me in my office hours. If you don't know about these functions, I'll be more than happy to discuss these with you. So if padding is true, then the output image will be an a nested list of zeros that will have the height and width of the image. If padding is not true, then in that case, the output image will be height, will be again a nested list, which will have the dimensions of height minus 2 twice the padding factor and width minus the 2 padding factor. Let's verify this, right, in order to understand this better. You had a filter 3 by 3, you had an image 1 of 5 by 5, and when there was no padding, the output image, the only these pixel values that are bounded inside this box were valid for the filter operation. And you can see that these pixels together form a 3 by 3 image, which is again precisely correct according to this formula, that height minus 2 twice the padding factor. In this case the height was 5 and the padding factor was 1, so height minus 2p is 3, and again width was also 5, the 5 minus 2p is again 3, so the output image will be a 3 by 3 image in case of no padding, which is again justified by the size of this bounding box, which consists of pixel values in the order of 3 by 3. Now, so we have created the output image, right, which will consist of zeros depending upon the height and width, or height minus twice of the padding factor, or width minus twice the padding factor, depending upon the input argument of the function. You have to incorporate both of these in your function. As I've already said, images are stored in the form of nested lists, so you will iterate through the list using a nested loop. First variable will iterate through the height, second variable will iterate through the width. At any point, if the I is minus the padding factor is greater than or equal to 0, and I plus the padding factor is less than or equal to height, then that's a valid row. And just to make sure that the column is also valid, what you will do is you will again take the j variable, subtract it from the padding factor, and check if it's greater than or equal to 0, and j plus the padding factor is less than or equal to width. It should be width here, not the height. Then the pixel at ij position is a valid pixel for filter operation. Compute the average. So you have to extract all the overlapping pixels at that position, all the overlapping pixels of the image, and then you will calculate the average. You can use numpy functions or you can do it manually. And then in the output image, you will assign that average value at these index positions. That would be 1 minus the padding, I minus the padding factor, and j minus the padding factor. If let's try to understand this with an example. So in this case, you can see that when I play 6 was not a valid operation for filtering, right? Valid pixel for filtering operation. In this case, the I and j are 0 0, right? When I subtract this I from the padding factor, which is 1 because the filter is 3 by 3, then the answer is minus 1, which is less than 0, right? So the row is invalid. Similarly, the column is invalid. Now in case of 9, here the row is valid because 1 minus the padding factor, which is 1, is 0, right? But in this case the column is invalid because the column is still 0. This position is 1 0, and you cannot apply the filter on this position either. So these formulas, these generic, if these two if conditions cover all the possible pixels where the filtering operation would be valid. And the interesting thing is, it would be, and the same if conditions would work for both. If you either you pad the image or you do not pad the image, it doesn't matters. These conditions will govern the pixel values where the filtering operation has to be applied. You have to think of how to extract the overlapping values, how to compute the average, and then assign those that average to these indexes at the output image. Then towards the end, return the image so you can print it, you can display it or check its pixel value. It depends upon you, whatever you want to do it, but display displaying the images is usually a good option for showing the effects of blurring or whatever the kernel you are applying. I hope this helps. If you need any help, you can post it in the discussion or you can contact me in my office hours. And that's pretty much it. Thank you.